Hi, I'm Mr. Eric. Today you're going to spend some time learning about patterns in motion. The question we want to try to answer is, how can science allow you to predict future events? Your goal today is you'll be able to identify patterns in the motion of objects by observing objects around you so that you can predict the movement of objects that move in a similar way. So to begin, let's review what causes objects to move.
On the slide, you can sometimes go slower or faster. What makes the difference? Have you ever thought about that? Think of the times you went down slowly and when you went down fast. What was the difference? Was the surface of the slide very shiny and polished, or sticky and in need of a clean? Was it wet or dry? Does it always feel the same going down a slide, whether it's very high or much nearer the ground? You can do some experiments at school to find out what makes a toy car go faster. Think of what might make these cars go faster down the slope. The children can change the slope. Sometimes it can be higher, sometimes lower. They are comparing different surfaces too. Some are much more slippy than others. Do you think the size or weight of the car matters? Sometimes pushes and pulls can make an object change shape. Can you think of any examples like these? We can push and pull Play-Doh into new shapes.
I'm going to change my shape by twisting it and squashing it. I'm going to change my shape by pulling it and pushing it. After I squash and squeeze it, it changes shape and it doesn't go back to its original shape.
What else can we do with it? The beanbag? It takes on a new shape when we push it around.
I made a square. I've made that's a curly shape.
And what about sand? It's been pushed into a new shape. What do you think will happen to the balloon? We don't usually think about why things move. Why do you go down the slide and not stay still at the top? Why does the swing go higher and higher? It's all to do with the pushes and pulls we give things. When windmills turn, it's the air which pushes the sails round, from the wind or from blowing on them. You can use the force of the air in your body to blow up a balloon or blow bubbles. Unless you used your breath to push against the bubble liquid, it would just stay there and do nothing. Water wheels turn when they're filled with the weight of water, which pushes down and makes the wheel move. Sand can do the same thing, push down on the wheel and make it turn. If something is moving, it means there's a force pushing it or pulling it. And it might not stop when you want it to. It can be dangerous to get near to someone on a swing, or the roundabout if it's moving fast. We know that cars are dangerous when they're moving. Bikes and skateboards can be dangerous too. How do you get this roundabout to start? Can you see how it gets started with a push?
Go.
And how does it stop? Kate pulls it to stop moving. It's the same with the swing. Watch how it goes faster and faster when it's being pushed, and stops when it's pulled from the back. How would you get this seesaw to move? It seems to be stuck in one place. It needs a push from their feet.
As you saw from the video, everything moves because of pushes and pulls. Watch the motion of these basketballs. What pushes and pulls are at work? How does he make so many baskets? You can definitely see he spent some time in practicing this game. To be able to make all those baskets, he has to rely on the ball moving the same way each time. In order to make that happen, he has to move the same way each time. Doing these things over and over again creates a pattern. Patterns allow us to predict how objects are going to move in the future. Here's another pattern. You know that if you sit on a swing, nothing happens. You have to be pushed by someone, or you have to push yourself by swinging your legs. Once the motion starts, you know that the swing moves back and forward until you stop moving or stop being pushed. Let's look at this model of motion.
So let's look at this model and see if our ideas about the patterns of motion work. So here I have a bucket on a string, and if I pull it up and let it go, it'll swing back and forth. Let's add a second bucket and see what happens. So here I have a smaller bucket, and I'm going to make it as small as possible. I'm going to make the other one as large as possible. So now if I bring them up together and drop them at the same time, what do you predict is going to happen? The blue bucket is probably about twice as heavy as the red bucket. Ready? Let's see what happens. Even though the blue bucket is heavier than the red bucket, they swing exactly the same.
All right, so we looked at the model. Now we're going to see if this works in the real world. I have some fishing weights here, different sizes, different masses, and we're going to, just to prove it to you, we're going to weigh these out. So I'm going to turn on my scale and change my units to grams. So we're speaking scientific here. So I'll put the big one on first. And the big one weighs 88 grams. Let's see what the smaller one weighs. Smaller one weighs 33. All right, so I have my pendulum set up, and I'm going to hang my weights on there. So I hang my weights by just using these little paper clips. So there's 1, 2, and let's let this spin a little bit. So now I have my pendulum weights hung there. Technical term for those are bobs. So, and they are just about the same weight, or same length. So I'm going to start my pendulum, and we're going to count how many times it passes this crack here in the door. Start them together. 3, 2, 1. So what causes this pattern? It happens because of a force we cannot see called gravity. For right now, all you need to know is that gravity pulls all things down equally. Watch as I drop the weights from our pendulum experiment. They hit exactly at the same time. Knowing that helps us predict how falling objects are going to move. Let's learn a little bit more about gravity.
Some forces will work without being seen by anyone. Your body is pushing down with a force called weight, and that's being created by gravity, a force from the centre of the Earth. Have you ever thought about why things fall when we let go? What is the force that makes this happen? It's one of the big forces we can't see. It's called gravity. Gravity is the force which makes things fall to the ground if you drop them. It's actually a force acting from the centre of the Earth, pulling us towards it.
Let's think about the patterns of motion caused by gravity in some of the sports we play. In baseball, a pitcher throws the ball. The batter knows where the ball is going to be based on the distance the ball travels and how much of a drop it has due to gravity. The catcher knows the same thing. Notice where his glove is. How about soccer? The player in white is heading a ball towards the goal. In order to do that, she has to know where the ball is coming from in order to meet it. The goalie also has to know where the ball might go next. In basketball, free throws don't go in a straight line. They have to curve up and over the rim in order to get to the basket, just like the video from the very beginning. Think about a bounce pass. Players have to know the angle the ball travels when bounced off the floor in order to get to the next player. Even in ping pong, we look for patterns in motion. Good ping pong players are able to hit the ball off the paddle onto the table of their opponent very quickly. The other player in turn has to predict where that ball is going to be in order to hit it back. For our last example of patterns of motion, we're going to get a little old school. Catapults have been around for a long time. People today use them to throw everything from pumpkins to pianos. Catapults can be extremely accurate if you can predict the pattern that works for you. Today, you are going to build and test a small catapult. Let's walk through how to build it. So here's what you'll need to make your catapult. I have a book. We'll use this to actually do the launching. I have a cup. That's our target. Marker. This is going to be kind of our fulcrum point. Our spoon, which is the main part of our catapult. Small piece of paper ball that's going to be used as our little projectile. I have a rubber band and tape. You can use either one of these to make your catapult, but I'll show you how to do the rubber band one first. So what you want to do is put your rubber band around the spoon, twist it once, and then you're going to put it over top of the marker like this, so it comes over top of the spoon. And just do that a couple times till you get a good secure footing there. When you're done, you should have something that looks like that. To do it with the tape, a little easier, just pull off some masking tape. Create your X. I'm going to put one that goes across the spoon like this. And one that goes underneath. Maybe one more just to tighten it up. The effect is the same. So the way you set this up is I have my catapult here, I have my target here, I'm going to put my paper ball in, and then this was where the book comes in. So this is what you're going to use to actually set your catapult off. So I'm going to try dropping it at different heights and see what happens. Oop, that one overshot. Try another one. And just adjust your book drop to different heights. A little closer. pretty close. Just keep fooling with it until you get the basket in. Think about what variables you can change each time and what variables you are changing each time to get that catapult on target. So, what have we learned today? Can you predict future motion? We know that motion happens because of pushes and pulls. Motions can be predicted based on patterns. Many predictable motions are due to the pull of gravity. Being able to predict motion can help you play sports better, and being consistent when making an object move makes it more predictable.